Hello guys, welcome to episode 4 of this tutorial. In this episode, we're going to start talking about promises, and you will see in action how promises can help eradicate the issue that callbacks cause. So the callback hell, right? Or the pyramid of doom. We talked about these two issues in the previous episode. So the objectives of this episode, we're going to talk about promises in JavaScript. We will learn how promises solve the callback hell problem. We will create our previous example with the 3 asynchronous operations for creating, updating, and deleting tasks using promises, and we will introduce then chain methods and catch chain methods. So these are the methods that you can use to run some piece of code after the promise, as they say, has been settled, so either resolved or rejected. Let's talk about the concept of promises a little bit. So promises in JavaScript are very similar to promises in the real world. So, in the real world, you promise to do something, but chances are you will fail. But you will try your best to fulfill that task that you have promised to do and return the result to the person you have promised the result to, right? So read the title. It says, I promise to do this, but chances are I'll fail. So a promise is an object in JavaScript. So it represents a value that may be available now, later, or never. So it has 3 states. A promise is an object that promises to create a value for you, right? So that value can be available now, later, 2 seconds later after communicating with the backend API, or never. For example, if the backend API is down, right? So a promise can be in 3 different states. It has 3 states. Pending is the initial state. As the name suggests, it means that the promise is in pending state. So it is not fulfilled, it is not rejected. You do not know whether it will be able to produce the value or not, right? Fulfilled means the promise has been fulfilled. So the promise has completed successfully, and the value that the promise is returning is available for you to process, to consume. And rejected means the promise, for whatever reason, couldn't complete. For example, the backend API was unreachable. It was down. So for whatever reason, the promise couldn't fulfill, and you have an error object that you can examine to investigate the issue. So instead of passing a callback, a promise returns an object that you can attach some chain methods, like for example then or catch. And then inside of these, you can write some code to kind of to do some processing based on the result of the promise. If, for example, the promise is fulfilled, the then chain method is going to do something with the data that the promise has produced. And if the promise fails, the catch chain method is going to get an error object. You can examine that error object inside a catch to investigate what the problem was. So using promises has a very big advantage. It removes that pyramid of doom issue that callbacks create. In the previous episode, we talked about this. So using callbacks, when you want to chain multiple asynchronous operations together, creates multiple levels of indentation, right? So that makes the code difficult to understand and difficult to maintain. With promises, that won't happen, and you will see this in action in this episode. So right now, I want to kind of rewrite the scenario from the previous episode using promises. So remember, we had 3 asynchronous operations: creating a task, updating a task, deleting a task, right? And we want to chain them together. So first we want to create a task, then we're going to update the task, and then we're going to delete it. 3 asynchronous operations are going to be chained together. So let's do this. First off, because I don't want to repeat a lot of code, I am going to write this generic HTTP request function, which is going to take in some parameters: method, URL, and data. And then, as you can see, it's going to return a promise. I told you a promise is an object. So I am creating a new object based on this type. And the syntax of a promise, take a look at this. This syntax is very important. a promise is an object that takes in an executor function. This is the function. So the executor function, this is the body of your executor function. So it starts here and then it continues, right? So this is the body of your executor function. The parameter that is passed to the constructor of the promise type is called the executor function. And the executor itself takes in two functions, resolve and reject. You use resolve when the promise has been fulfilled, when the promise has completed successfully. And you use reject when the promise has been rejected. The promise could not fulfill for whatever reason. So let's see what is going on here. So inside of the executor function, which is taken in two functions, these are the functions that JavaScript provides. So inside of the executor function, we are going to communicate with the backend API, as you can see here, using the method and URL that we receive as input parameters, right? We are going to communicate with the backend API using the URL, and then if everything goes according to the plan, we're going to resolve the promise. So we're going to call the resolve, right? And as you can see here, we are going to parse the value that the XHR request has returned. So response.text. We're going to, resolve the promise. We're going to return the resolve to resolve the promise with this value. But if for whatever reason this asynchronous operation fails, we're going to call reject. And we're going to create this new error object. So again, the executor function is the only parameter that you pass to the constructor of a promise. And that executor function as input parameters takes in two functions, resolve and reject. You do your asynchronous operation inside of the executor function, and you can decide when you're going to resolve the promise and when you're going to reject the promise. If, for example, there is an error, you're going to reject the promise as well. So now this is a very generic method, HTTP requests, returning a promise. Now we can write some consuming code to call this HTTP request, which is going to return a promise, and then on that promise we can chain other functions, like for example then or catch. So let's take a look at this one. We have three asynchronous operations. All of them are using that HTTP request generic function that returns a promise. And they are returning whatever they receive from this HTTP request function. So the URL, the methods, as you can see here, right? And the task or task ID and so on. So we have one very generic method or function returning a promise, and we are calling that using different parameters. Now, let's chain these three asynchronous functions together. So this is the create task that we're going to, call. So with a task, right? And then we know that create task is going to call that HTTP request function, which will return a promise. Because this create task is going to return a promise, we can chain this chain function onto that. And in this chain function, we are consuming the value that the promise returns when the promise is fulfilled. So for example, we're going to say that when we're creating a task, right, if everything goes without any issues, we're going to receive something from the backend API. So whatever we receive, we're going to console log that in this then function. And of course, afterwards, we want to call another asynchronous function, which in this case is the update task. And again, we're returning this here as well. So returning means it will return another promise that you can, again, chain with a then here. Again, you're going to consume the value that the update task returns if everything goes according to the, without any issues. And then you're going to return another promise from the delete task. We all know that create task, update task, and delete task return promises. And then for delete task, you're going to again add this then, and you're going to console log this. We know that for delete task, right? We are going to call the HTTP request with the delete, HTTP method, and then with this URL. And then we are going to have a catch block. So a catch block kind of catches the errors. If the promises are rejected, are not fulfilled successfully, there's going to be an error object. And we decided to do that here. So when we're rejecting the promise, we are constructing this new error object. So when we are catching this, we are actually getting access to that error object. And we're going to print out the message property of that error object. So let's go through the explanation again, and then let's write the code. So HTTP request is a promise-based wrapper around XML HTTP request. Each task function returns a promise, as I told you. We chain the operations using then for linear flow, and if any step fails, the catch handles the error. Take a look at this. The code doesn't have a lot of indentation levels. It is very clean, even though we are chaining multiple asynchronous operations together. It is very readable, very maintainable, very easy to understand compared to the code we wrote in episode number 3 with callbacks. Now let's go to VS Code and write this. I am in episode number 4. I'm going to create this new file, episode 4. And first off, I'm gonna write the generic HTTP request function. So we already talked about this, right? We're taking 3 parameters: method, URL data. We're gonna return a promise, the executor function, which takes 2 functions itself, resolve and reject. Let's do the asynchronous operation of communicating with the backend API, and then reject or resolve the promise based on the result that asynchronous operation returns. We need to decide where we want to reject the promise, where we want to resolve that promise. So this is the generic function that we needed. The next step is to create those 3 methods or functions: create task, update task, delete task. All of them are going to use this generic function, HTTP request. So this is create task. The next one is going to be update task. So we have achieved some level of reusability as well. And then the last function. Now we want to call them one at a time and chain them together and handle the results that each will return, and of course catch any issues. So create task, we're going to pass in the task, and then we're going to add this then function to it. We're going to return another promise using update task. Let's consume the result of that promise as well using the next then function, and return another promise, delete task, and then consume that as well. And catch any issues that might occur. So we're done. As you can see, we have the result of our 3 asynchronous operations printed one after the other, right? And if I come up with an issue, for example, let's say in the update task, we are going to communicate with this, for example, URL. So as you can see, the task created is successfully carried out, but for the next one, which is the update, we have this error. And of course, we get the error here as well. It says, the message is error connection refused, network error, right? So the errors are kind of, examined, are kind of, this block is going to catch the issues, the errors that happen along the way. But if anything goes, if everything goes according to plan, using these three code blocks, we will see the result of these three asynchronous operations in our browser. So let's continue with the notes. This is the output. Let's wrap up this video. So in this episode, we talked about promises. We refactored callback hell into cleaner, then chains, and we created reusable, readable HTTP logic with a generic HTTP request function. And that's it for this episode. We're not done yet. We're not finished. We have some more concepts to explore and to cover. So I invite you to watch the upcoming videos as well.